sine omega t minus pi by 2 means theta minus 90. So based on that I write I is equal to minus E naught of L omega minus of sine omega t minus 90. This 90 can be written as what? A pi by 2. And this minus minus can be cancelled. Then I is equal to E naught by L omega sine omega t minus pi by 2. So this is the expression for instantaneous current in AC source AC EMF flows in a inductor E naught by L omega. So this E naught by L omega can be written as what? I naught. So finally I can write I is equal to I naught sine omega t minus pi by 2. So this is the equation number 1. You can say this is the equation number 2 finally. Compare the equation number 1 and 2. 1 and 2. The EMF, the AC EMF leads that current, instantaneous current in the inductor by an amount of pi by 2 because it has got minus pi by 2. Again I repeat, AC EMF leads that instantaneous current by an amount of pi by 2. So how to write in a phasor diagram? So draw a x-axis and y-axis. Who is actually leading in the inductor? Your voltage is leading. So that's why it's standing and so active. So this is the EMF in the inductor. And who is actually, yes, very lazy fellow and lagging behind? And the current. So the I in inductor. So what is the phase difference? Is 9 degree is equal to pi by 2. So this is a simple phasor diagram. Will give you an idea who is leading and who is lagging. EMF in the inductor is leading than that of the current in the inductor. So how to draw the wave diagram for both inductor for instantaneous current and instantaneous EMF. So draw a x-axis and y-axis. Along the y-axis instantaneous EMF and AC source, AC EMF and instantaneous current are taken along the y-axis, and then along the x-axis the theta is equal omega t is taken. You draw a AC source, namely E, as you have seen earlier. You can say this is a pi by 2 and this is pi and this is 3 pi by 2 and this is 2 pi. But we have understood that current is lagging. So lagging means you have starting point of the current in the negative direction is actually lagging by an amount of pi by 2, and then draw like this and go. So when you start that current wave in the negative direction, when it meets pi by 2, so that current is lagging by an amount of, lagging behind the AC EMF in the inductor by an amount of pi by 2. So next we will move on to the what? AC circuit with a capacitor. And before we go to the capacitor, we have to see a few important idea with inductor. I naught is equal to E naught by L omega. That's correct. So this is exactly resembling the Ohm's law. So I is equal to V by R. So in the place of a resistance, what is actually acting? L omega. So L omega, but in the case of inductor I can say I naught is equal to E naught by XL. So XL is called L omega. So the XL is otherwise called inductive reactance. XL is called inductive reactance, is a resistance offered by the inductor against the flow of an AC EMF. So L omega is the resistance offered by the inductor against the flow of AC EMF, is otherwise called an inductive reactance. So you know that L omega is equal to 2 pi nu. So we can write XL is equal to L into 2 pi nu. And when you if you don't pass the AC, but if you pass the DC, for DC the AC, the frequency is equal to 0. So XL is equal to 0 for DC. And XL since, and look at this example, and XL is directly proportional to the frequency. So this is for AC. I repeat it again. Since the frequency of a DC is equal to 0, and inductor will not offer any resistance against the flow of a DC. So the DC will flow through the inductor very easily without any opposition. And the amount of opposition or impedance offered by, the resistance offered by the inductor depends upon the frequency of the AC. And greater is the AC frequency, and greater will be the inductive reactance offered by the inductor. So the inductive reactance offered by the inductor against the AC will depend on the frequency of the AC which flows through it. So based on that, one understanding question will be asked: why does the DC flow? Why does DC flow through the inductor very easily? You have to write the question. You have to explain an entire topic and say, and XL is equal to 0. Okay. And next we will move on to the inductor AC circuit with the what? The capacitor. So same way, a capacitor having capacitance C is connected across AC source. So you have studied in the second chapter, not even the second chapter, first chapter itself you have studied. The capacitance of the conductor is equal to C is equal to Q by V. And if you want to calculate, and Q is equal to C into V. And this V here in this fourth chapter taken as E. So Q is equal to CE. So Q is the Q of a charge flowing through the capacitance when AC flows through it. When AC flows through it, can be written as Q is equal to CE. So this AC EMF supplies, this AC source supplies EMF P is equal to E naught sine omega t. And I is equal to, you know that, I is equal to dq by and dt. They have studied under the definition of electric current in the second chapter, the first page of the second chapter. So it is equal to d by and dt of and q. What is called q? This can be substituted over here, and CE. So I is equal to d by dt of CE into E naught. So this E naught, E can be substituted over here, and E naught sine omega t. When you differentiate IEC, when you differentiate, this is called, C is a constant, E naught is a peak current, is also a constant, sine omega t becomes what? It's very simple, cos omega t. So C E naught cos omega t. But if you want to express cos omega t in terms of sine, so I is equal to C E naught. So when you differentiate, no, one more omega will come. C E naught omega sine omega t plus 90. That 90 becomes what? Pi by 2. But this can be written in a different way. I is equal to E naught 1 by C omega sine omega t plus pi by 2. The whole numerator denominator can be taken as what? I naught. So now I can write I is equal to I naught sine omega t plus pi by 2. So you can consider this equation number 1. The last expression can be taken as what? Equation number 2. Compare the equation number 1 and 2. So what's an idea you get it? The EMF, AC EMF, lags behind that AC instantaneous current when flow through the capacitor by an amount of pi by 2, because it has got plus. So in the case of a capacitor, the instantaneous current leads that AC EMF by an amount of pi by 2. So now we can draw a phase diagram. Draw x-axis and y-axis. Who is very active and going and leading in the capacitor? Current in the capacitor is leading. And who is lagging and very lazy and sleeping? And in EMF. So EMF in capacitor is lagging. So what is the phase difference between them? It's pi by 2, 90 degree. So this simple phasor diagram, with this one can able to understand who lags and who leads when AC flows through and capacitor. And how to draw the wave diagram. So draw an x-axis and y-axis. Along the y-axis, AC EMF and instantaneous current flowing to the capacitor can be taken. Along the x-axis, theta is equal to omega